So for this session, let us continue our review, and we are now on the following problem. Okay, so sketch the graphs of x equals negative square root of y equals x, and x plus y equals 2. Well, it's written there on the grid below, but you can disregard this part here. And then find the point of intersection of each pair of equations. Okay. And then the next problem here, find the area of the region that is enclosed by the graphs of these three functions here. So let's start with the sketch. Let's have this x-axis and y-axis. So we have here the y-axis. This is your x-axis. And then let us start with x equals negative square root of y. So that this guy here, okay, this guy here, you can rewrite this as what? You square both sides, you will have y equals x squared. Okay. Now, it is written this way. Okay. We have x equals negative square root of y. It means that when you try to sketch this, the graph of y equals x squared, you will only take the negative x's. Okay? Of course, y equals x squared, it will look something like this. Okay? Something like this. And then, since you only want the negative values for x, okay, you will only draw this part here. Okay? So for that, let's try to draw it. So we have something like this. Okay? So this is the sketch of x equals negative square root of y. Okay? And then we have y equals x. Okay? I'll use a different color here. We have y equals x. We have this graph here. So assume this is y equals x. And then we have here x plus y equals 2. Okay? So let's just get 2 points. And then we connect the 2 points to get the line x plus y equals 2. So when x equals 0, you will have your y equals 2. So say this is 1, this is 2. And then here we have 1 and 2. So when x equals 0, y equals 2, we have this point. And then um, when y equals 0, we have x equals 2. So we have this point. So if we sketch this, we will have the line that looks something like this. Okay? It will look something like this. Oh, the pink one looks red also. Let me change the color for that one. Maybe I'll use orange. So you have this point here, you have this point here, and then you will have the line that will look something like this. Okay, so this orange line here, this has equation x plus y equals 2. Okay, and then we want to find the points of intersection, or the point of intersection of each pair of equations. So for the points of intersection, let us start with the pair x equals negative square root of y and um, x plus y equals 2. X plus y equals 2. So for this, we want to find the point of intersection that is located here. Okay, so you have this guy here, x equals negative square root of y, and then you have this line here, x plus 2 x plus y equals 2. So this is the point of intersection we are interested in. So how do we solve this? Well, you have your x equals negative square root of y, and then you have x plus y equals 2. So from this guy here, we can just write y. We can write x equals 2 minus y. Okay, so x plus y equals 2. You can write this as x equals 2 minus y. And then we substitute this to the equation here, which means that we will have 2 minus y equals negative square root of y. And then we just solve for y, and then we will get the value for x. Okay, after solving for y. And then we will obtain the point. So we square both sides. We'll have 2 minus y quantity squared. This is equal to y. Or we will have what? 4 minus 4y plus y squared equals y. Okay? And then we will have, we simplify this, we bring this y here to the other side of the equation. We'll have y squared minus 5y plus 4 equals 0. And then what is this? We'll have y minus 4, y minus 1 as the factored form of this equation here. Okay, and that's equal to 0. So we can easily solve for the values of y. If you want to use your quadratic formula, you can also do that. Okay, but if you can factor it, immediately, then that's better. Okay. Now, there was a question, where does the minus before the square root go? Well, if you square this guy here, that minus will just disappear. Square of negative 1, that's positive 1. So it will disappear. Okay. So now in here, in this guy here, we will have y equals 4 or y equals 1. Correct? And then we solve for x. So we got these two possible values for y. It could be both. But as you can see in our sketch in here, okay, we only have one point of intersection. So we have to get which point is that. And of course, you can guess. It's high up here, so maybe it's the higher number for y, which is y equals 4. But let us solve that mathematically. Well, algebraically. So when y equals 4, we can substitute the value of y in here, either in here or in here, to find the value of x. Okay? But let us use this guy here. So the value of x, this is equal to negative square root of 4, which means that x equals negative 2. Okay? X equals negative 2. On the other hand, for this guy, when y equals 1, we will have x equals negative square root of 1. But this means you just have x equals negative 1. Correct? Good so far? Now, let us try to analyze this. So you got 2 points. you have negative 2 comma positive 4. And then the other point here, it's negative 1 comma 1. But which is which? Okay? Both values of x here, they are both negative. Okay? But which one? Is it the one with negative 2? Okay? Or is it the other point, the one with negative 1? Now look at this. This guy here is y equals 1. On your Cartesian plane, this is y equals 1. And take note that this is y equals 1. This guy here, it's above 1. And this guy here, it's way above 1. Okay? It's way above y equals 1. This is your y equals 1. This is way above y equals 1. Which means that this point here is this guy, or has coordinates given by this guy here. Therefore, this point here it's negative 2 comma 4. Okay, so we take this point here. So that's for this for the pair x equals negative square root of y and x plus y equals 2. Okay. Now, let us consider the pair y equals x and x equals negative square root of y. Okay? So let me go to the next page first. So we are now looking at the pair x equals negative square root of y and y equals x. Now this is easier. Okay? Y equals x or x equals y. This means that you will have here y equals negative square root of y. If you square both sides, you will get y squared equals y. Okay? Or you will get y squared minus y equals 0. And you will have here y times y minus 1 equals 0. Okay? So for this, either you have y equals 0 or y equals 1. Okay? Y equals 0 or y equals 1. And then we again test. Okay? We test we find the values of x. Okay? So for this, you'll just have x equals 0 because you have y equals x. Okay? Or x equals negative square root of y. In here, however, you will have what? According to this equation here, okay? According to this equation here, it would give us x equals 1. Okay? And then, according to this equation here, okay, it will still give us, okay, it will give us x equals negative square root of 1, which is negative 1. Okay? So, which is which? Is it y equals 1? Or this point here, if we consider this point here, you will have the point 1 comma 1. If you consider this point here, you will have the point negative 1 comma 1. This guy here, okay, this guy here, it's a no-no because take note, you want to intersect it with this point, or yeah, you want to intersect this with this curve, but your x's must be negative. The x value here, it's positive, so it cannot be this guy here. Possibly it's this guy, because, well, your x is -1. Okay, your x is -1. But if you look at the graph, x equals -1 will be on this side. So it cannot be x equals -1. Okay? So the only point now is this guy here. This guy here, which has coordinates 0, 0. Okay? So far, so good. So there was a question, why did you remove the negative from y? Again, we square it. We square this guy here. So we square them. That's why we have y squared. And of course, the square of this -1 will become +1 after squaring. Okay? So now, we have this point of intersection here. We have verified it's just 0, 0. Okay? Lastly, we want the point of intersection here. This guy here. Okay? So it's the pair. It's the pair y equals x and x plus y equals 2. So we want to do y equals x and x plus y equals 2. Let's use another page. Okay? So we want the pair y equals x and x plus y equals 2. So again, y equals x, so we can replace y by x or x by y. And this means that you will just have y plus y equals 2, or you will have 2y equals 2, or y equals 1. Correct? And this means you have x equals 1. So for this pair of curves, the point of intersection is 1, 1. So if we go back to the sketch, we have this point here, 1, 1. Okay? Questions? Okay. So we solved the second problem now. Find the area of the region that is enclosed by the graphs. Okay? So let me just copy that sketch and add another page. So we have this sketch here. Let me put it up here if it's okay. Yeah, maybe we can. Yeah, let's put it there. And then let me just adjust the. All right. So for this, our region will be, so the one that is enclosed by all of them. Okay? By all of them. So here's the region. This guy here, all right, the green ones, this is the region we want. Okay? So we want to find the area of this region. You can do it either with x as your variable of integration or with y as variable of integration. But in both cases, you will have to divide this into two parts. Okay? So let's just use x as our variable of integrations. It means that our strips would be vertical. So if we use vertical strips, at this part here, you will have this vertical strip here. And then at this part, you will have this vertical strip. On this part, the above function is this line here. And the below function is this parabola here, or part of the parabola. On the other hand, for this, the above function, it's this yellow line in here. And then the below function, it is this line. So we have to divide this into two parts. Okay? So you will have two integrals with two different intervals. Even if you do this horizontally, for example, you got this horizontal strip here, okay? The above function, it's the yellow, it's the line, the yellow line. Sorry, not the above function, but the right function, it's the yellow line. While the left function, it's the parabola. Okay? So the right function, it's the yellow line, while the left function, it's the parabola. But when you go to this part, the right function, it's the blue line, and then the left function, it's the parabola, which means you will also need to divide that into two parts. So whether you do it with respect to y or with respect to x, almost same amount of work is needed. So let's just use verticals. So the area, okay, take note, we need y in terms of x. Since we are doing vertical strips, our variable of integration, it is x. So again, for this part here, we write this as y equals x squared. Okay? Here we have y equals x, so it's totally fine. For this guy, we isolate y. We will rewrite this as y equals 2 minus x. Therefore, area will be the integral. Let's start with this part here. So the above function, it's the yellow line. Okay? The below function, it's the parabola. The variable of integration will have interval starting from this, which is at -2, until this point, which is at 0. Okay? So this guy here, this is at -2, and of course, this is 0. So we have the integral from -2 to 0. Above function, the yellow line, which is 2 minus x, minus the below function, it's the parabola, y equals x squared. So minus x squared in here. And then we have the dx. And then for this side, okay, we add the area of that region. The integral will be from 0. It's starting at this point and it will end at this point. Okay? And this is when x equals 1, which means the integral is from 0 up to 1. Okay? The above function, it's still the yellow line. So we have 2 minus x. The below function, it's the blue line, y equals x. So we have here minus x. So above function minus below function. Then we have the dx here. Then we'll just evaluate this. So we will have 2x minus x squared over 2 minus x cubed over 3, evaluated from negative 2 to 0, plus here we have 2 minus 2x, okay? 2 minus 2x. So if we integrate, we will have 2x minus x squared, evaluated from 0 up to 1. Therefore, if we evaluate this, at 0, this is 0 minus quantity. At, sorry, we should, yeah. So at 0 here, and then at negative 2 now, we will have 2 times negative 2 minus negative 2 squared over 2 minus negative 2 cubed over 3. That's for the first integral. For the second integral, we will have plus 1, or at x equals 1, we have 2 minus 1. And then at x equals 0, it's just 0. So we'll have just 0 in here. So if we simplify this, we will have negative of negative 4. Negative 2 squared, that's 4. And then 4 over 2, that's just 2. So we have minus 2 here. And then negative 2 cubed, that's negative 8. So we will have here plus 8 over 3. And then plus 2 minus 1, so it's just plus 1. So simplifying this guy here is just negative 6. Negative 6 plus 8 over 3. That's negative 10 over 3. So we will have negative of negative 10 over 3. And then plus 1. So we will have here 13 over 3. So this is the area of that region. Okay? So for our next problem, let R be the region that is enclosed by the graphs of y equals 4 minus x squared and x plus y equals 2. So this is the figure. So we have the parabola here, which is y equals 4 minus x squared, and we have this line here, which is x plus y equals 2. So our problems are, first, find the volume of the solid of revolution that is generated by revolving R about the x-axis using the method of washers. And then for the number 2, we want to find the volume of the solid of revolution that is generated by revolving R about the line x equals 3 and using the method of cylindrical shells. Okay? So let us do this. First, let us consider number 1. So um, we want the solid that is generated by revolving the region R about the x-axis. Okay, so we have this axis of revolution here. Okay, and then we want to find the volume using method of washers. So remember, when we use the method of washers, the rectangular strips that we are going to consider should be perpendicular to the axis of revolution. So in here, the axis of revolution, it's the x-axis here, which is horizontal. So we need to get vertical rectangular strips. So here we have this vertical strip here. We also have this vertical strip here. And as you can see all throughout, the above function here, it's the parabola y equals 4 minus x squared. And then the below function here is the line x plus y equals 2. So as the vertical strips move from left to right, we will need the leftmost endpoint, which is at this point, and this occurs at x equals -1. And then the rightmost endpoint is here, and this is at x equals 2. Okay? Now, since we are going to use vertical strips here, okay, we have to write the functions as y in terms of x. So for this guy here, we don't have any problem because it's y in terms of x. For this guy, we write it as y equals 2 minus x. Okay? Now, if we revolve this about the x-axis, let's get a strip, and after the revolution, we will get this washer here. So we consider this rectangular strip here, and then we revolve it, and we obtain this washer. Okay? So remember, in the method of washers, we need to consider the outer radius or the bigger radius, and then the smaller radius. Okay, so in here we will see that this is the bigger radius, so it is from the center or from the axis of revolution going to the farther function. That's your bigger radius. And the smaller radius will be from the axis of revolution going to the nearer function. Okay, so for the bigger radius, we have this. From this axis of revolution going to the farther function, and that's your 4 minus x squared here. So the bigger radius, it's 4 minus x squared. While the smaller radius, it's from the axis going to the nearer function, and we have the 2 minus x. Okay? So remember that you need the bigger radius. It's from the function or from the farther function to the center or to the axis. Then the smaller radius, it's the nearer function going to the axis. So if we now use our formula, the volume will be, okay, the integral from -1, okay, from -1 up to +2. So you see here, -1 up to +2. And then we have pi. And then we have the bigger radius squared minus the smaller radius squared. Okay? And then we expand these two guys here. Okay? And we will obtain the following. So in here, I just put the pi outside of the integral. And then here we expanded. We have 4 minus x squared squared. So we have 16 minus 8x squared plus x to the 4. And then you have this minus here. That's why there's a minus here. And then we expand this and enclose it inside parentheses. So if we expand this, we will have 4 minus 4x plus x squared. And then we simplify, okay? So here, we continue the computation here. We simplify, so equals pi times the integral from -1 up to 2. So we have there 16 minus 4, that's just 12. Then we have minus -4x, so that becomes plus 4x. Then we have minus 8x squared minus x squared. So we'll have minus 9x squared. And then we have the plus x to the 4. And still we have the dx. So again, we just simplified this expression. We distribute the negatives and then we combine them with the ones in here and the constant. And then from here, we'll just have to evaluate. So this will be pi times 12x plus 4x squared over 2. Let me write it as 2x squared minus 9x cubed over 3. Let me write it as minus 3x cubed. And then we have plus x to the 5 over 5. Then we evaluate this from -1 up to 2. Okay? And then evaluating, we have here pi times. At 2, we will have here 24 plus 2 times 4, that's 8, minus 3 times 2 cubed, so 3 times 8, that's minus 24, plus x to the 5, that's 32 over 5. Then minus, at -1, we have here -12. And then we have plus 2. And then -1 cubed, that's -1. So we'll have plus 3 here. Then -1 to the 5, that's still -1. So we will have -1 over 5 in here. And then we close the square bracket. And then we'll just have to simplify this. Equals pi times. Here we can cancel this and this. And then for this guy here, this is just -7. Okay? But there's a minus there, so it becomes plus 7. So we will have 8 plus 7. That's 15. And then here we have 32 over 5. This guy here, it's negative. This is also negative, so it becomes plus. So here we will have plus 33 over 5. And then 15 times 5, that's 75. So we will have here pi times 75 plus 33 over 5. So this is just 108 over 5 pi. So this is the volume of that solid. Okay? So that's for number 1. For number 2, this time we want to get the solid of revolution, okay, by revolving the region R about the line x equals 3. So this is the axis of revolution here in this case. Sorry, it should be at x equals 3. But anyway, so we have this. And then we want to use methods of the cylindrical shells. Okay? The method of cylindrical shells, the strips we're going to use should be parallel to the axis of revolution. So this is the axis of revolution, which is vertical. Strips will still be vertical. Okay? So just like before, all throughout, the above function, it's your parabola. The below function, it's your line. So again, let me get this strip here. And if we revolve this about the line x equals 3, we'll get this cylindrical shell here. Okay? Okay, pardon my sketch here. Then of course, you have this, the thickness there. Okay? Now, the height of your cylindrical shell here. The height of your cylindrical shell, it's this guy here. So it's this function, the above function, minus the below function. So height, this is equal to above function, which is 4 minus x squared, minus the below function, again, y equals 2 minus x there. So you have 2 minus x. That's the height. The radius, or the mean radius, okay, the mean radius. So this is where your mean radius is. That's just x. So from that point up to this point, so it will be 3 minus x. So in here, the average radius, it will be 3 minus x. Still, the interval is from -1 up to +2. Therefore, the volume will be the integral from -1 up to +2. Then you have your 2 pi times the radius, which is 3 minus x, times the height, 4 minus x squared minus 2 minus x. In parentheses there. And then you have your dx. Okay? Questions? And then let us calculate this. First, let me bring out 2 pi. Then we will have here integral from -1 up to 2. And then we have 3 minus x. And then we simplify the one in the square bracket. We have this 4 minus 2. So we just have 2 there. And then we have here minus negative x. So it becomes plus x. And then you have your minus x squared dx. And then we multiply this. 3 minus x times 2 plus x minus x squared. So we have 2 pi integral from negative 1 up to 2. So for the first one, we will have here 3 times 2. So I'm just gonna distribute this over the addends there. So we have 6 plus 3x minus 3x squared. And then I'm gonna distribute negative x to each of these addends over there. So I will have minus 2x minus x squared plus x cubed. Then the dx in here. And if we simplify this, we have 2 pi integral from negative 1 up to 2. Why did I put 1 up there? So if we simplify, we can combine the 1's with the x's and the x squareds. So in here, I will get 6 plus x minus 4x squared plus x cubed. Then we have the dx. Now we are ready to evaluate. So 2 pi times 6x plus x squared over 2 minus 4x cubed over 3 plus x to the 4 over 4 evaluated from negative 1 up to 2. So let us calculate this. We have 2 pi and then quantity. At 2, we will have 12 plus 2 squared, that's 4. 4 over 2, that's 2. Minus 2 cubed, that's 8. 4 times 8, that's 32. So we have 32 over 3. Plus, we have x to the 4, that's 16. 16 over 4, that's 4. So we have plus 4 in here. Minus quantity. At negative 1, we have here negative 6 plus 1 half minus, actually it's plus 4 thirds because negative 1 cube, that's negative 1, and we have negative somewhere in here. Somewhere in here. So it becomes plus. And then we have plus 1/4. And then just simplify this and you will get the volume. Okay? So just continue working on this and try to simplify it. Let's now go to our next problem here. Let f of x be this integral here. Okay? So f of x equals the integral from 1.1 up to cosecant x dt over t times t squared minus 1, where x is from pi over 4 to pi over 3. Okay? First, Find f prime of x. So for the first one, we just need f prime of x. We have here f prime of x. It's just the derivative with respect to x of this 1.1 up to cosecant x. You have your dt divided by t times t squared minus 1. The derivative will just replace the t with the cosecant of x because it's already an upper limit of integration. The lower limit of integration here, it's just a constant. So if we do that, we'll just have 1 over cosecant x times cosecant squared x minus 1. And then by chain rule, we need to multiply this by the derivative of cosecant x. It's just cosecant x, actually negative cosecant x cotangent x. Okay? If we simplify this guy here will cancel this. So we will have negative cotangent x. The denominator will apply identity. Cosecant squared x minus 1, that's cotangent squared x. Therefore, if we further simplify this, we'll just have negative 1 over cotangent x, or this is negative tangent x. So this is f prime of x. Okay? For number 2, look at this interval, pi over 4, comma pi over 3. So the interval was chosen so that you can apply the formula for the arc length. Okay? So anyway, let's just directly apply the formula for arc length. The arc length formula, it's just the integral from pi over 4 up to pi over 3 square root of 1 plus f prime of x quantity squared dx. Okay? So there was a question for the part 1. I used the fundamental theorem of calculus. Okay? So that's the first part. That's actually the statement 1 of the fundamental theorem of calculus in our course. Okay? That's my first statement for the FTOC. So, anyway, let us continue. So we substitute f prime of x, the one that we obtained from the first part. So integral from pi over 4 up to pi over 3 square root of 1 plus negative tangent squared. That's just, sorry, negative tangent x quantity squared. That's just tangent squared x. Okay? The negative will disappear because you're going to square it. But what is this? 1 plus tangent squared x. This is just secant squared x. So in here, you'll just have integral from pi over 4 up to pi over 3 square root of secant squared x dx, or simply we have integral from pi over 4 up to pi over 3 of secant x dx. Now, without the limits of integration, this guy here, we have to put absolute values. Okay? That's one of the definitions of absolute value. So let me put that. So this is square root of x squared. And this is the same as the usual definition. X if x greater than or equal to 0, negative x if x is less than 0. So anyway, on the interval pi over 4 up to pi over 3, the values of secant are positive. That's why we don't have to put the absolute value. Now, integrating secant, that's ln, absolute value of secant x plus tangent x. And then we evaluate this at pi over 4 until pi over 3. So if we simplify this, or if we evaluate this, we'll just have ln absolute value, secant of pi over 3. So cosine of pi over 3, that's 1/2. So secant of pi over 3, that's just 2, plus tangent of pi over 3. Tangent of pi over 3, that's just square root of 3. Then minus ln absolute value. Secant of pi over 4, that's square root of 2, plus tangent of pi over 4, that's 1. So this is the arc length of the curve y equals f of x over the interval pi over 4 comma pi over 3. Let's move to our next problem. Determine whether the integral is convergent or divergent. Evaluate if the integral is convergent. Okay? Evaluate if the integral is convergent. So let's see. This is an improper integral because you see here from 0 to 1, but at 1, when you replace that here, you'll have 1 minus 1 on the denominator and it becomes 0. So the function 1 over square root of 1 minus x squared, it is discontinuous at x equals 1. So this is an improper integral. Okay? So let us do this. We have the integral from 0 to 1 dx over square root of 1 minus x squared. By definition, this is the limit as t approaches 1 from the left. Then you have the integral from 0 to t. Then you have dx over square root of 1 minus x squared. Okay? If you don't remember the formula for this, okay, especially if the integral of dx over 1, square root of 1 minus x squared, you can't remember, you can always use your trigonometric substitution. That's what we're going to do here. So integral dx over square root of 1 minus x squared. So for this, we let our x to be sine theta, dx will be cosine theta d theta. So this will just be the integral of cosine theta d theta divided by square root of 1 minus sine squared theta. Or this is just the integral of cosine theta d theta over square root of cosine squared theta. You should end up with um, integral of d theta. So this guy here, this is just theta plus c. But using this guy, theta, this is equal to sine inverse of x. So in here, we have sine inverse of x plus c. Okay? Which means if we go back to our original problem, if we continue, we will have the limit as t approaches 1 from the left. This is just sine inverse of x evaluated from 0 to t. This is the limit as t approaches 1 from the left. You'll have sine inverse of t minus sine inverse of 0. That's just 0. So this guy here, this is just sine inverse of 1. And sine inverse of 1, this is just pi over 2. So we have a limit. Therefore, this improper integral from 0 to 1 dx over square root of 1 minus x squared is convergent. And the answer is this guy here. Okay? Let's go to our next problem. Determine whether the integral is convergent or divergent. Evaluate if the integral is convergent. So we have another improper integral in here. Okay? And this time it's infinite interval. So the integral, okay, from 0 to plus infinity of e to the x over 5x plus 1 dx. Okay? Now, for this part, we will show that this is not, this is divergent. Okay? We will show that this is divergent. To do that, we will use the comparison test for improper integrals. Okay? Comparison test for the improper integrals. So how do we do that? How do we do that? Observe. Observe for x greater than or equal to 0. 1 will be less than or equal to 1 plus 5x. And this guy here implies that 1 over 1 plus 5x will be less than or equal to 1. Hmm. Uh, no, I think this is a bad comparison. So I am saying that for this guy here, this is a bad comparison because what we will end up with is the following. We have e to the x over 1 plus 5x less than or equal to 1 over 1 plus 5x. Okay? And if I integrate this part, this expression here, I will get some ln. Okay? I will get some ln in here. And what will happen is, if we integrate this over the interval 0 to plus infinity, we'll get infinity, which means the integral of this from 0 to plus infinity of dx, okay, is divergent. Okay? But we cannot conclude anything for this. Okay? So my bad, on the right-hand side, I will have e to the x. So if anyway, if I integrate this from 0 to plus infinity dx, this is still divergent, so we cannot conclude anything for this guy here. Okay? So this is not helpful. Not helpful for us. Now, this is what we're going to do instead. Still, observe that for x greater than or equal to 0, okay, 1 plus x will be less than e to the x. Okay? 1 plus x will be less than e to the x. If you don't believe that, the graph of y equals 1 plus x will be something like this. So this is 1 in here. This is negative 1 in here. So for 1 plus x, it will be something like this. So this is y equals 1 plus x. On the other hand, e to the x will be something like this. So they will intersect there, but it will rise up there. So here you have y equals e to the x. E to the x will be greater than 1 plus x for all x, actually. Okay? And then, also, so we have the equality in here, by the way. We have the equality there. Also, 1 plus 5x, this is greater than 0. So what we're going to do, divide everything by 1 plus 5x. The inequality will not change. You will have 1 plus x over 1 plus 5x. This will still be less than or equal to e to the x over 1 plus 5x. So now, all we need to do is to integrate this and show that this is divergent. Okay? If this is divergent, so is this guy. Okay? And then, let us play with this guy here. Let us actually multiply 5 on both sides. We will have 5 plus 5x over 1 plus 5x. This will be less than or equal to 5e to the x over 1 plus 5x. Now, we get integral from 0 to plus infinity, okay, of 5 plus 5x over 1 plus 5x dx. Let me adjust all of this. So by definition, this is just the limit. As t approaches plus infinity, integral from 0 to t, the 5 in here, I will decompose this into 1 plus 4 or 4 plus 1. So I will have 4 plus 1 plus 5x, then divided by 1 plus 5x dx. So this guy here, we have the limit as t approaches plus infinity, integral from 0 to t. I'll separate the 4. We will have 4 plus 4 over 1 plus 5x dx. And then we will have here plus integral from 0 to t dx. Following? So if I separate them, I'll have this guy here and then this guy here. But they are both 1 plus 5x, so they will just cancel. It's just 1 on this part. Okay? And then if we calculate this, still we have the limit as t approaches plus infinity. For the first guy in here, we have 4 ln absolute value of 1 plus 5x over 5 evaluated 0 to t. And then for the other guy, it's just x evaluated 0 to t. Okay? Let me erase this left side here and then move again all this stuff. Actually, I'll just move this part here. Is it just that part? Yeah, whatever. I'll just move this part. And then evaluating, we'll just have here equals limit as t approaches plus infinity. The other guy, it's just 4 over 5 ln of absolute value of 1 plus 5t minus ln of 1. Ln of 1, it's 0. And then plus, and here x at x equals t, it becomes t, and then again at 0. But this guy, as t approaches infinity, this is plus infinity. Okay? So what does this mean? This means integral from 0 to plus infinity of 5 plus 5x over 1 plus 5x dx is divergent. So the bigger expression will also be divergent. So this means that you have 5 integral from 0 to plus infinity of e to the x over 1 plus 5x dx. This is also divergent. Okay. Let's go to our next problem. So in here, we have, so same problem, same instructions, but we need to do the integral from -1 to 0 of e to the 1 over x cubed dx. So for this, again, this is an improper integral because, well, you have a denominator, x, and you are integrating from -1 to 0. Particularly, this is discontinuous at x equals 0. Okay? Okay, so let us do this. Originally, we have this guy here. I mean, the problem that we want to solve is the integral from -1 up to 0 of e raised to 1 over x divided by x cubed dx. Okay? And this is improper integral. So we apply, we use the definition. We have the limit as t approaches 0 from the left, integral from -1 up to t, e raised to 1 over x divided by x cubed dx. Now let's work on the integrand first. Okay? We want to integrate e raised to 1 over x cubed dx. The first thing that we need to do here is substitution. Okay? Say, let s be equal to 1 over x. ds, this is -1 over x squared dx. Now look at this. The original, this guy here, we can rewrite it as integral from integral of e raised to 1 over x divided by x squared times. So I'll just leave the x squared there. You have, yeah, I'll write x squared times x. And then you have the dx. So you have the 1 over x squared. You have this 1 over x squared. You also have your 1 over x, this guy here. So if you do the substitution, you will have negative integral of s e to the s ds. Okay? The negative, it's because of this guy here. 1 over x here, it's s. That's why you have your e to the s in here. And then there's still 1 over x somewhere there. So that's your s. And then the 1 over x squared together with this dx here, that's your ds. And then from here, from this guy here, we'll just use integration by parts. So let u be equal to, so liate, let u be equal to s, dv be equal to e to the s, ds, du this is ds, v this is e to the s. So we have negative integral, okay? Negative integral, sorry, we have the negative quantity, uv, so that's just s e to the s, minus the integral of v du, e to the s ds. So if we continue, we'll just get here negative s e to the s plus e to the s plus arbitrary constant c. And then we bring back our s or our x. It's s equals 1 over x. So anyway, I'll stop the computation for this part here. Then I'll now continue with our original problem. So this is just the limit as t approaches 0 from the left of quantity negative s from here, okay, from here, but we will replace s with 1 over x. So in here we will have 1 over x e raised to 1 over x, okay, and then plus e raised to 1 over x. Then we evaluate this from negative 1 up to t. Okay. And evaluating, still don't forget to write that limit there. Limit as t goes to 0 from the left. We evaluate, we'll just have negative e to the 1 over t over t. Okay. So let me just clarify this. And then plus e raised to 1 over t. Okay. Minus at negative 1, we'll just have e raised to negative 1 divided by negative of negative 1, that's positive 1. And then plus here, we have e raised to negative 1. And then we evaluate the limit. Okay. Now, some more work in here. Okay. Let me use another page. So in the previous page, we want to solve for the limit of e to the 1 over t divided by t. Note that as t goes to 0 from the left, 1 over t this goes to negative infinity. And therefore, e raised to 1 over t will go to 0, which means this is 0 over 0. Okay? This is indeterminate form of type 0 over 0. So we can apply L'Hopital's rule. Okay? So if we do this, we will have something like limit as t approaches 0 from the left, and then we get the derivative of the numerator. If we do that, we will have negative 1 over t squared e raised to 1 over t. For the denominator, we'll get 1. But notice this expression got worse. Okay? This expression got worse. So instead of applying L'Hopital's rules on this expression here, we will rewrite this guy here. Okay? What we are going to do is to put this on the denominator, and then 1 over t. Of course, there will be 1 over t in this part. I'll put that in the numerator. Okay? So let us rewrite this. This one can be written as the limit as t goes to 0 from the left of 1 over t divided by e raised to negative 1 over t. Okay? They are the same. I put this expression here on the denominator, the exponent becomes negative. So what about this? Again, 1 over t will go to negative infinity. Here, e raised to negative 1 over t, this will go to plus infinity. Therefore, this now is of type infinity over infinity. So we can still apply L'Hopital's rule. But in this form, we have a better answer. Why? Because in here, we will have the limit as t approaches 0 from the left. Derivative of 1 over t, that's negative 1 over t squared. And then derivative of e raised to negative 1 over t, we will have e raised to negative 1 over t times 1 over t squared times the derivative of 1 over t. And notice this guy here will cancel this guy here. And therefore, this expression here, we will now be able to write it as negative e raised to 1 over t. Here, our t goes to 0 from the left. This is just equal to 0. Sorry, it's not equal to 0. It's, oh yeah, it's equal to 0. Remember this part here. So take note, this is now in the numerator. That's why this negative here disappeared. Same explanation as this guy here in the numerator. We brought it to the denominator. That's why we have a negative. Okay? So what's the point? This limit, it's equal to 0. We go back to this. This means that these two guys here will just go to 0. Okay? It will go to 0. And therefore, the final limit will just be negative 2 e raised to negative 1. Or you can write this as negative 2 over e. So either this guy here or this guy in here. So this guy here, this is convergent. Okay? Questions? Let's now go to our next problem. Consider the graph of y equals 1 over 1 plus x squared over the interval 0 to plus infinity below. Use the graph to evaluate the integral from 0 to 1 of the square root of 1 minus y over y dy. So find the area of the shaded region. That's the hint. Now look at this. Okay? This guy here, if you do this, actually you will not be able to do this using the methods that we know, using the techniques of integration that we know. So we will be using this guy here. Now, from here, from this expression here, okay, this guy here we can write as 1 plus x squared. This is equal to 1 over y, correct? And this guy here will have x squared equals 1 over y minus 1. If we combine this into a single fraction, this will be 1 minus y divided by y. Which means that we will have x equals plus or minus square root of 1 minus y divided by y. Okay? So this equation or this graph here, you can rewrite this in terms of x in terms of y. You just have the equation x equals square root of 1 minus y over y. We only take the positive side because as you can see, your x is just positive. It's just on the positive side of your x-axis. So we just take the positive side. Okay? Now, what is this integral here? Okay, what is this integral here? It's the integral from 0 to 1 square root of 1 minus y over y dy. This will give us the area of this region here. But since we are using the variable y, this will be horizontal. We are using horizontal strips. Okay? But again, as I have said, you will not be able to integrate this using the methods that we know. However, look at this. Instead of calculating the area using horizontal strips, let us try to calculate this using vertical strips. Okay? The area will be the same, correct? If we calculate the area using vertical strips, it should be the same as the area. Um, it should be the same if we use horizontal strips instead. Okay? But if we use vertical strips, it means that we need to use this form here. Y in terms of x. Y in terms of x. This means that this integral here, integral from 0 to 1 of square root of 1 minus y over y dy, this should be the same as the integral of 1 over 1 plus x squared dx. But this time, this will run from 0. So from this point, going to infinity. So in here, we have 0 to plus infinity. And if you look at this is easier to integrate. So again, this guy here, okay, it's the same, it's equal to the area of the shaded region, but you are using horizontal strips. Look at this, the horizontal strip here will run from 0 until 1. So that's your integral there. We calculate the same area, but this time using vertical strip. This vertical strip here will run from left to right. So it's from 0 to plus infinity. You have this. And we need the function to be y in terms of x. This is that function. That's why we have this guy here. So this is an improper integral. We just calculate, we write the definition. Limit as t approaches plus infinity, integral from 0 to t, dx over 1 plus x squared. I hope you remember that this uh, integral dx over 1 plus x squared, it's your tangent inverse. So this is t going to plus infinity, or limit as t goes to plus infinity of tangent inverse of x evaluated from 0 to t. This guy here, it's the limit as t approaches plus infinity, tangent inverse of t minus tangent inverse of 0. Tangent inverse of 0, that's just 0. So it won't contribute to anything. And recalling the graph of tangent inverse, okay? The graph of tangent inverse, you have the asymptote here. This is at pi over 2. The graph will be something like this, approaching pi over 2. And here, it approached negative pi over 2 down here. Okay? So, the limit as t approaches plus infinity, this is just pi over 2. Okay? Questions? Now, let us go to our last problem for the session. So, gamma of x, so the gamma function is defined as gamma of x integral from 0 to plus infinity of t raised to x minus 1 e to the minus t dt. Okay? Find gamma of 1. And then we show that gamma of x plus 1, it's equal to x gamma of x. So for the first one, gamma of 1 here, take note, this is x, this is x. The integral here, it's with respect to t. So x here, it's just constant in this integral. Okay? So, gamma of 1, this is the integral from 0 to plus infinity. T of 1 minus 1 e raised to negative t dt. T of 1 minus 1, that's just t to the 0, which is 1. So this guy here, it's just the integral from 0 to plus infinity e to the minus t dt. Again, improper integral. So we use definition. So this guy here, we will have the integral from 0 to t e to the minus t dt. So this is just the limit as t approaches plus infinity of negative e to the minus t. Sorry, I'm using bad notation, very bad notation. Instead of t here, this should be s. I'll use another parameter for the limit. So I'll use s here. I'll also use s here. So this guy here, it's also s. So this time here, we are evaluating from 0 to s. So it's bad notation because I'm already using my t as my variable of integration. So I have to use another variable for my limit. So I'll use s instead. Okay? So anyway, continuing, we have here the limit as s approaches plus infinity. We will have here negative e raised to minus s minus negative e to the 0. And as s goes to plus infinity, e to the minus s will go to 0. This is just equal to 1. So gamma of 1, this is equal to 1. Okay? Next, we have here number 2. Show gamma of x plus 1, this is equal to x gamma of x. So there's a hint. Use integration by parts. You start on the left-hand side. Gamma of x plus 1. So for gamma of x plus 1, this is the integral from 0 to plus infinity of t raised to x minus 1. But your x will be replaced by x plus 1, correct? So x plus 1 minus 1 in here. Then we have here e to the minus t dt. Okay? And this guy here, it's just the integral from 0 to plus infinity of e to the t to the x, e to the minus t dt. And the hint, use integration by parts. So if we do that, here, Liate, algebraic comes first before exponential. So u, this is t to the x, dv, this is e to the minus t dt. Take note, we are integrating and differentiating with respect to t. So in here, du, this is x t raised to x minus 1. And then v here, this is negative e to the minus e to the t. Sorry. So negative e to the minus t. So in here, uv v du. Okay? So first, improper integral. So limit as s approaches plus infinity. Integral from 0 to s. T to the x e to the minus t dt. So this becomes limit s approaches plus infinity quantity uv. So this will be minus t to the x e to the minus t, okay, minus the integral from 0 to s. By the way, in here we evaluate this first guy here from 0 to s. And then the second guy, you will have b du, b du. So you will have here negative of x t to the x minus 1 e to the minus t dt. Okay? So let me copy this part here. And then from here, we just need to solve the limit. Okay? So far, what we have is that gamma of x plus 1. So we calculated this, and that's equal to this expression. Okay? This guy here, as s approaches infinity, okay, after evaluating, it will go to 0. So let us just write first. We have limit as s approaches infinity. So for the first one, we'll just have negative s raised to x e raised to minus s minus, at 0, you will have negative 0 to the x e to the 0. So this guy here, okay, this guy here, it's equal to 0. Okay? You only need to show now that this guy here, okay, will go to 0 as s approaches infinity. But what about this guy? We have this negative. We have this negative there. So it becomes plus, okay? And then you have this x here. Take note, the variable of integration, it's t. So x is constant. So x is constant. It can go out of your integral. So this will be x integral from 0 to s. What remains inside there, it's just t raised to x minus 1 e to the minus t dt. Okay? And now, the difficult part here is this guy. As s approaches plus infinity. But you see, this guy here, okay? This guy here, um, it's just s with an exponent which is a positive number. Okay? This guy here, if you bring it to the denominator, you have the exponential. Okay? But exponential grows faster than this guy here. Okay? If x is any real number, it will be difficult to solve this guy. I mean, to find the limit. If x is an integer, it will be easier. Integer because for this, it becomes polynomial if n is integer. And we can easily integrate polynomial times your e to the s using continuous integration by parts. Okay? So for this, I'll just say claim without proof. Okay, I claim without proof that the limit as s goes to plus infinity of e to or of s to the x e to the minus s, this is equal to 0. I'll just claim it without proof. Okay? So using this guy here, it will mean that I will get x integral from 0 to infinity t to the x minus 1 e to the minus t dt. I now let this s go to infinity. That's why I have this infinity. But look at this. This is exactly this guy here, correct? And that's just your gamma x. This is x, gamma x. And now we have proven that gamma of x plus 1 it's equal to x gamma x. So that's the end of the proof.